All right, thank you so much for joining us today. And in this video, we are going to talk about method of variation of parameters. So we started the idea that anytime we have our complementary solution, then we can do a guess for a particular solution and we can use method of undetermined coefficient to solve it, right? But now what if the question is asking you to use the method of variation of parameters? Then you cannot use the method of undetermined coefficient. So now anytime you have your complementary solution, then with the use of the method of variation of parameters, what we are going to do is the same complementary solution, we are going to write it for the particular solution. But here is the difference. We are going to change the C to U1 and then C2 to U2. But here, this and this are constant, but here they are functions of what? X, so that we can solve it and come and multiply it to this. And we saw that when I did the solution, I said, now for us to find u1 is equal to minus the integral of y2, which is here, times gen of x, which is equal to what is here. I didn't bring the y2, which was that gen of x is the non-homogeneous aspect of the equation, and then the same thing for this. So just remember this formula here and then how to write this one, and you'll be good to go. And then I said this is the Wronskian, and that is basically what is here. So let's take example to practice, and then we see how we can go through the process. So this question here, we can use the method of undetermined coefficient, right? And to solve it, to solve the non-homogeneous aspect. But the idea is that here we want to use the method of variation of parameters. So it's also almost the same thing as the process, like the process that we go through. So for us to find the general solution, we need to have our complementary solution in addition to our particular solution. So it's kind of the same thing. So for complementary solution, the same thing, y prime, y should be equal to 0. Then our y should be e to the power mx, y prime will be equal to m e to the power mx, and then our y prime prime will be equal to m squared e to the power mx, right? So let's do the substitution. M squared e to the power mx plus e to the power mx is equal to 0. Factor it out, and this one will be m squared plus 1, which is equal to 0. And guess what will happen? This is never 0, and m squared plus 1 should be equal to 0. So let's find for m squared is equal to minus 1. Take square root of m squared, take square root of minus 1, and m will be equal to plus or minus I. So now that we've gotten this one, this is what we are going to do. Now we are going to write our complementary solution. And remember, whenever we have a complex, then we need to use ux k1 cos vin x plus k2 sine vin x, right? So here our u is 0 and our vin is 1. So this is going to be 0 k1 cos x k2 sine x, right? Good. Then when I simplify this, I get k1 cos s plus k2 sine x. Good. So this is my complementary solution. So we are coming to make use of the complementary solution. Now this solution that I've gotten here is the same as you writing something like k1 y1 plus k2 y2. This implies that y1 is equal to cos s, and then y2 is equal to sine x, as we can see from the formula that we have here. So the formula that we have here, we have C1, but here C1 is our K1, and then C2 is our K2 also here, right? So Y1, it was the function that was multiplying the constant, which is this, and then Y2 is also this. So looking at this, you've gotten Y1 and y2. So now we can guess, or we can assume our particular solution, right? So assume yp to be equal to, so we say that it should be assuming that ux and then y1, right? So y1, okay, so let me write everything. Y1 of x plus u2 of x, y2 of x. So if we assume this, we know that we don't know u1, but we know y1. Y1 is cos s, plus we don't know u2, but we know that y2 is sin x. So this is the guess for our particular solution. So what we are going to do is we are going to look for u1 and u2 using this formula right here to determine it, right? So let's write the formula down. Let me write the particular solution here. So yp is equal to u1 cos s plus u2 sin x. Now we know that y1 is equal to cos s, y2 is equal to sin x. Now before we use the formula here, we need the Wronskian, right? So we need to find a Wronskian. So we know that y1 is equal to minus y2 gen of x divided by the Wronskian of x dx, and the y2 is y1 gen of x divided by the Wronskian of x dx. Now what is gen of x? The gen of x is the non-homogeneous aspect of this, right? So here gen of x is equal to sin x. So let's go and write it down here. So our gen of x is equal to sin of x. Now before we use the formula, we need the Wronskian. So what is the Wronskian of x? So the Wronskian, we said the Wronskian should be y1, y2 on the first row. So what is y1? Y1 is cos s, and what is y2? Y2 is sin x. And then the second row, we should be differentiating the y1 here and differentiating y2 here. So when I differentiate cos, I get minus sine. Now when I differentiate sine, I get cos. So now let's find the determinant. That's the Wronskian. So determinant, this multiply this and this multiply that. So cos times cos is cos squared s, minus sine times minus sine is minus sine squared x, and this is cos squared x plus sine squared x, and we know that this is an identity and it's equal to 1, and then the Wronskian is never 0. One thing that you need to know is here the Wronskian cannot be 0. Anytime the Wronskian is 0, then it means that our function here, our solution here, y1 and y2 are not linearly independent. So we stated it here that y1 and y2 should be linearly what? Independent. It means that if they are linearly independent, then when you find the Wronskian, you will never get it to be 0. So that is basically what we wanted to do here. So now that we've gotten the Wronskian, let's compute u1. So u1 is going to give us something like minus y2 is sine, and gen of x is also sine. So we are going to have sine x divided by 1, because the Wronskian is 1, and this is the same as minus sine squared x dx. So now the idea is that with this question too, after you figure out this, you need to be able to figure out your integration. So it's very, very important here. So I'll show you how to do integration with this. Now with sine x squared, we cannot integrate directly. So we need to use identity to figure out what is sine x squared equal to. Now we just saw that when I add cos squared and sine squared, I'm going to get 1. So it means that basically here I can deduce something from here. It means that sine squared x is equal to 1 minus cos squared x when I move this guy to this side, right? So one identity. So I have the squared in, so I need to change the square because I can replace this by this here. But since I have squared here, I still need to reduce it. But we know one identity that says that, which identity? Yes, we know one identity that says that if I have cos if I have cos A plus cos B, then this is the same as cos A cos B minus sine A sine B, right? So what I can do here is I can say that then cos S plus X is the same as cos S minus sine X. Good. So this is going to give us cos 2x, which is equal to cos squared x minus sine squared x. So now we need this guy. So let's make it the subject. So cos squared x is equal to cos 2x plus sine squared x from here. Then now I'll plug in this here. So I'm going to have something like this. So what I'm coming to do when you finish is good to know the process, but you need to keep it in mind. Because for me, I will know that this is equal to what I'm going to derive. So I just plug it in there and then I just start working with it. So this is minus in bracket 2x plus sine squared this. So simplify this, you get 1 minus cos 2x minus sine 2x, and then this is sine squared x. So I have sine squared here. I can move this one here and have sine squared s plus sine squared x, which is equal to 1 minus cos 2x cos 2x. Then add them together and we are going to have 2 sine squared x, which is equal to 1 minus cos squared x. We need just sine squared x, so I'm going to divide this one by 2 and divide this one by 2. And you see that sine squared x is equal to 1 minus cos 2x divided by 2. So I know that this is true. Anytime I have this one, this is equal to this. So I could have just replace it straight away and just do the integration, but you may not understand. So that's the reason why I went through the process. So know the process and know this one, that this is equal to this. I'll give you the bonus tip. The bonus tip here is when you have cos squared x, this is equal to 1 plus cos 2x divided by 2. So when it is cos, it is plus, and when it is sine, it is minus, right? You can use the same process to do it, the same process starting from here, but here you are going to make cos x squared a subject from here, and then you go through the same process and you will see that this one is going to be what? Plus. So these are something that you should be able to have it in mind. So now that you know them, let's go through the process. So I know that this is the same as minus, this is the same as 1 minus cos 2x divided by 2 dx. So let's do the integration. Minus, this is the same as 1 over 2 minus cos 2x divided by 2, or I can even factor 1 over 2 out. So let me do it that way. Minus 1 over 2 out, 1 minus cos 2x dx, right? Then let's do the integration. So 1 over 2, when I differentiate 1, I get x, because it is the x that when I differentiate, I'll get 1. Good. Then when I integrate cos, what am I going to get? When I integrate cos, I get sine. But this is change rule, right? So I'm going to get minus, the minus is already here, and then I'm going to have sine 2x, but this is change rule. So when I finish, I need to do something to the 2x. So I'll differentiate 2x and get 2 and use it to divide. So that is one thing about how to do integration. So this is what I'm going to get for my integration. And when I multiply through by half, I'm going to have minus 1 over 2x plus sine 2x divided by 4. So this is u1. This is u1. Let's look for u2. u2 is equal to y2. So u2 is y1. u2 is y1 times gen of x. So what is y1? y1 is cos, and then gen of x is sine. So we are going to have something like cos s sine x divided by 1 dx, and this is sine x, this dx. So this is what we need to integrate. So now what can we do with this? So this, so one thing about this is anytime you see integration, you'll be able to figure out which rule are you going to use. So this one, I'm going to use integration by part to do this, because integration by substitution is not going to work. Yes, integration. Let me see integration by substitution. If I let u to be equal to cos s, then du over dx will be equal to cos. It's going to be minus sine x. So let me see. Oh, okay. Integration by substitution will work from here. Is that right? Yes. Okay, so let's use integration by substitution. So always you need to remember your integration techniques. So if I let u to be equal to this, then du over dx, this is going to be minus sine x, right? And this implies that du is equal to minus sine x dx, right? Now we can see that we have sine and dx here, so I can make sine and dx the subject here. So I will divide through by minus, and I have minus du is equal to sine x dx. So what I'm going to do is now my integration now will move to this one here, will move to equal to integration. We know that cos is equal to u, so I'm going to have u times, then I know that sine dx, which is here, is equal to minus du, so times minus du. Very simple from here. And then I'm going to have this one to be minus u du, and when I integrate u, this is to the power 1, so I'm going to have something like this. I think it's better for me to push these guys up small from here. Oops. Okay. So let me just push this guy here, followed by this guy. Good. Then I can clean this guy and then move this guy here. Good. So using the power rule, this is going to give us minus u squared divided by 2. And we know that u is equal to cos. So this is going to give us equals minus cos squared x divided by 2. So this is what I'm going to get for u2, right? Now that I've gotten u2, I'm going to plug it inside the particular solution. So I have u1, u2. So let me do that. Let me just clean a solution here and just plug in there. So this is going to give us yp. What is u1? u1 is minus half x plus sine 2x divided by 4, all times cos x plus or minus cos squared x divided by 2 sine x. So this will be the particular solution. This will be the particular solution. Then we add the particular solution to this complementary solution. What is the complementary solution here? So let's do that. We are going to have something like this. The general solution, y is equal to, complementary solution is k1 cos x plus k2 sine x plus minus 1 over 2x plus sine 2x divided by 4 cos x minus cos squared x divided by 2 sine x. So this will be the general solution when we use the so for example, if you understand how to use um, variation of parameters and you know how to use a method of undetermined coefficient, then when the question is open, you will choose one, the one that you want to what use. But be careful whenever you are choosing variation of parameters, your integration must be good because variation of parameters is kind of very simple when you are using to do it. But if you understand a method of undetermined coefficient too, that one too become very simple for you to also do it. Now let's try another one. This is a polynomial function, right? So we can think of using the um, undetermined coefficient, but here we want to use the variation of parameters. So let's go through the same process again. Let's find for yc, right? So for yc, y prime prime plus 4y should be equal to 0. Good. And then here we are going to have m squared mx plus 4 mx is equal to 0. So I hope we understand this step. And then I'll factor mx out. And I have m squared plus 4 is equal to 0. And then mx is not 0. M squared plus 4 should be giving us 0. And then m squared is equal to minus 4. Take square root on both sides. And this is going to give us m, which is equal to plus or minus 2i. So now that we are getting plus or minus 2i, this is a complex one. So we need to have something like this. Our complementary solution is going to give us something like this. Let me see. Okay, this is going to give us something like, so here u is 0, so this is like kind of u 0 here. So ux k1 cos vn x plus k2 sine vn x. So this is going to give us e to the power 0 k1 cos 2x plus k2 sine 2x. Simplify this and we are having complementary solution to be k1 2x plus k2 sine 2x. So immediately we get something like this. We need to guess the particular solution. So we are going to change this one to u1, which is in terms of x with the cos, right? So this is very simple to write. And then k2 to u2 with the sine. Good. So that's the particular solution that we need to get from here. Then now we need to ask ourselves, what is gen of x? So from the question, gen of x is equal to x. Good. So gen of x is equal to x. Then what is y of x? That is y1. Y1 is the one that goes with k1. So this one should be giving us cos 2x. And then y2 is the one that goes with k2 from here, or c2. So this is sine 2x. So what we need to do here is, now we know that u1 is equal to minus y2 gen of x divided by the Wronskian dx. u2 is y1 gen of x divided by the Wronskian dx. So we need the Wronskian. So let's find the Wronskian. And we know that anytime we have this guy, the Wronskian, it's kind of going to give us either 1, or because this one is 2, it's going to give us 2. So let's find the Wronskian. So the Wronskian is equal to y1, which is cos 2x, y2, which is sine 2x. And then when I differentiate this, I get 2 sine 2x, and this is going to be 2 cos 2x. So let's multiply. This times this is going to give us 2 cos squared x, and then this times this will be minus. So minus minus will be positive. So this one's also 2 plus 2 sine squared x. Factor 2 out, and we're having cos squared x plus sine squared x. And this is going to give us 1, right? So we are going to have 2 times 1, which is equal to 2. So it's the Wronskian is not 0. As soon as the Wronskian is 0, we cannot use the variation of parameters. So now that we've gotten the Wronskian, which is this. We know y2, we know gen of x, y1. We can find the u1 and then u2. So let's do that. u1 is equal to minus y2 is sine 2x times gen, and this is divided by 2. So this is what you are going to get, and this is the same as minus 1 over 2 x sine 2x. So here we need to figure out how we are going to do the integration, and here we don't have any option by using integration by part. So we need to remember our integration technique. Integration by part formula is u dvn, right, is equal to u vn minus vn du, right? So what we are going to do is we compare. This guy is this. So here what we need to choose is we need to choose anytime we have trig function and a polynomial function, we choose the polynomial function to be u, and then everything left is for dvn. So I'm going to choose u to be x and my dvn to be equal to sine 2x dx. So I chose this guy. For u. Then everything left, which is sine 2x dx, is for dv. So now that we've done the let, now we need to look at this guy here. We need u is here. We need vn, we don't have it, so we can get vn from this by integrating. So let's do the integration. I integrate dvn, I integrate sine 2x dx. When I integrate sine, I get minus cos. So this is going to give us vn, which is equal to minus cos 2x. Then I will divide it by, when I differentiate what is inside the bracket here, what is going to give us 2. So we've gotten u and we've gotten vn. Now vn is also here, but we need the u. We can get the u from here by differentiating this with respect to x. So du over dx is equal to 1, and du is also the same as dx. So we've gotten du also here, so we can just plug them in. So let's see what we get. We are going to have this to be equal to minus 1 over 2 in brackets. So now that we compare this to the one here on the left, then when we are writing this, we are looking at basically what is here. So let's do substitution. U times vn. So we are going to have minus s cos 2x divided by 2 minus integration of vn du. So vn is minus cos 2x divided by 2, and dvn is dx. So dvn is dx. So that's what we just need to do. We are done. So now let's go through the process by doing the simplification. So minus 1 over 2 minus s cos 2x divided by 2. Now this is going to give us plus 1 over 2, because when I bring the minus and this will be out, then it will be left with cos 2x dx. So let's do the integration now. Minus s cos 2x divided by 2 plus 1 over 2. Now when I integrate this, we know that when I integrate cos, I get minus sine. So minus sine. Then I divide it by when I differentiate what is inside the parentheses there. Good. Now I can just simplify this by multiplying through by minus half. So this is going to be x cos 2x divided by 4. Then I have minus here, making positive. 2 times 2 times 2 is going to give us 8. So plus sine 2x divided by 8. So this is u1. This is u1. Then we need to think about u2. So u2 is equal to integration y1 gen of x divided by the Wronskian dx. Now y1 is cos, right? So we are going to have cos 2x times gen of x divided by 2 dx. So we go through the same integration by part again. 1 over 2 out. This is s cos 2x dx. So the same integration by part again. U is equal to x, du over dx is equal to 1. It implies that du is the same as dx, right? And then here our divin will be equal to cos 2x dx. And then when I integrate both sides with integration, I'm going to have vin to be equal to, when I integrate cos, I get sine. So I'm going to have sine 2x. Then I divide it by the derivative of what is inside the parenthesis, which is going to give me 2. Good. So what I need to do is, now I need to make sure that I just go through the integration by part formula that we use it here, and then boom, we are there. So this is going to give us, u2 is going to give us 1 over 2 in parentheses. So integration by parts, u times vin. So u times vin, we are going to have x sine 2x divided by 2 minus integration vin times du. So vin times du. So we are going to have sine 2x divided by 2 dx. So now let's try and then do the simplification, and then we do the integration. So 2x divided by 2, I'll factor the 1 over 2 out, and it will be left with this dx. Now let's do the differentiation, then we are done with this question. Now when I integrate sine, we've done it, so I'm going to have cos okay, when I integrate sine, I get minus cos. So this is going to give us minus cos 2x divided by 2. Good. Let me check something here. There's a mistake somewhere. So when we differentiated sine, we get minus cos, and then when we come here, oh, I did a mistake somewhere here. Yes, because when I differentiate cos, I should have sine. I said it, so this one should be minus. So when I differentiate sine, I get minus. But when I integrate cos, I need to get positive sine. So minus will affect this one here. Is that right? Yes. And then here, when I integrate cos, I'll get sine. And then when I integrate sine, I get minus cos. Good. Okay. We are almost there. So let's do the simplification. This is x sine 2x divided by 4. And this one will be rather plus cos 2x divided by 8. Good. So we've gotten u1 and u2. So we can just plug them in, and then we are done. So we are just going to substitute it inside this. So let me just copy this and send it there, with including this one too. So I'm going to have, good. So I have my complementary solution here. My particular solution now will be equal to u1 was x cos 2x divided by 4 minus sine 2x divided by 8. Then I'll multiply by cos 2x, then plus u2 is what we had here, sine 2x divided by 4 minus or plus cos 2x divided by 8 times sine 2x. So this is u1 times cos, and then this is u2 times sine. So our general solution is going to be this plus the whole of that. So y will be equal to k1 cos 2x plus k2 sine 2x plus the whole of the particular solution here. So let me just copy this one and just paste it. Good. So plus this. Then, so the whole of this big thing is our particular solution. Good. So I said particular. This will be the general solution. So you see that with the variation of parameters is the integration, which matters a lot. So you should be able to go through your let me say your integration very well, right? Some of the integration too you cannot do it, so you can just leave it in the integration form. So we have the last two questions to go. So now let's look at this one to what we can get from here. So we start by saying that for complementary solution, y prime prime minus 3y prime plus 2y is equal to 0. So for me, I like using the variation of parameters, and it's because it's very short. You don't do a lot of guessing and then a lot of differentiating two times before you go and just do substitution. But if you don't know how to do integration too, then you don't need to come to variation of parameters, but you also need to learn how to do integration too as well. So now let's go. M squared e to the power mx minus 3 times m ex plus 2 times mx is equal to 0. Factor this out. M squared minus 3m plus 2 is equal to 0. And then emx is never 0. M squared minus 3m plus 2 is equal to 0. And then here, can we do some factorization here? 2 numbers, okay, we can do that. So this is going to be minus 2m plus, no, minus m plus 2 is equal to 0. Good. So the one with the red and then the one with the green. Red is going to be this, minus 2. And this one, when I factor 1 out, I get this minus 2 is equal to 0. So the one with the red, I'll factor it out. And then what will be left is this is equal to 0. So let's see what happens here. M minus 2 is equal to 0. M is 2. M minus 1 is equal to 0. And M is 1. So let's write the complementary solution. Complementary solution will be C1 e to the power m1x. So let me make m1, m2, plus C2 is this. So as you are doing it, you should be remembering what we've learned long time ago. This forms. So this is going to be 2x plus C2 e to the power x. So as soon as I get, so that's one thing about using variation of parameters. As soon as I get this one, I know my guess solution already. So my guess solution is always the same, constant. U1 of x times this, plus I change the C2 to U2 of x times that. So this becomes my trial solution for this one. Then what I need to do is now I need to look for my y1, which is the one which is going with the C1 or K1 or any constant that you are using. So 2x, and my y2 will be this. Good. Then what will be my gen of x? That's also one thing that I need. So I look at the function and it's equal to e to the power x. So that one is going to give us e to the power x. Then I need my Wronskian, right? So I just need my Wronskian. So let's find the Wronskian. The Wronskian is y1, which is 2x, and then y2 here. Differentiate this and get 2, this, and differentiate this and get the same thing. Let's find the determinant. This times this is going to give us e to the power 3x. Then minus this time this is going to give us 2e to the power 3x. And this is going to give us minus e to the power 3x. And this is never 0, right? So this is going to be the Wronskian when we solve this. Good. Now what we are going to do is, now let's go through the process. Somebody can choose this one to be y1 and this one to be y2, and this is going to be positive. but it's also going to be the same when we are choosing our solution. So I know that u1 is equal to minus y2 gen of x divided by the Wronskian dx. u2 is equal to integration of y1 gen of x divided by the Wronskian dx. So now let's go through finding u1. So we know y2 to be this times that divided by the Wronskian. So I'm going to have minus ex times ex divided by the Wronskian. What is this? The x. So simplify this and we are having e to the power 2x divided by minus 3x dx, and minus minus will be positive, and then this and this is going to give us e to the power minus x, right? So we have like indices, the base are the same, so we need to subtract the top, and this is what we are going to get, and this is dx. So when I integrate this, I'm going to have e to the power minus x divided by, then I differentiate what is on the top, which is going to give me minus 1, and this is minus ex. So this is very simple to do a lot of guess. Then u2 will be equal to y1 is e to the power 2x. So e to the power 2x, e to the power x, which is the gen of x, and then the Wronskian is minus 3x dx, which is going to be, this is going to give us e to the power minus e to the power 3x divided by 3x dx. So I factored the minus out, which is here, and then this one will cancel this. So I'm going to have minus 1 dx. What function, when I differentiate, I get 1? It's x. So this is going to give us, yes, minus x. We are done. So my particular solution is equal to, so you see that using variation of parameters is kind of very simple, very straightforward, but the only thing here is you always need to know how to do your integration. So this is going to be times e to the power 2x and then plus or minus x e to the power x. Is that right? What was the particular solution? We chose this one. So let me go and compare it and see if I'm doing the right thing. So this is the, okay. So u1 is this, and then this times that, which is here, and u2 is this, so times that. So when I simplify this, I have minus e to the power 3x and then minus x e to the power x. Let's add it to the complementary solution and get the general solution. So general solution is going to give us y is equal to, what is the complementary solution? Okay, so complementary solution is a particular solution without this, so e2x plus c2 e to the power x. Then I add a particular solution, 3x minus x e to the power x. Good. So this is going to be the general solution. Good. Good. So you see that variation of parameters are very, very simple when you know how to do the integration or differentiation, right? Do we do differentiation here? Yeah, okay, for the first homogeneous aspect. Let's do this last question. I'll give you one question to try and you leave your answer in the comment section. Right. So now let's see what we can do to also from here. So here we are saying that x should be greater than 0 because the length function, the domain, is defined when x is greater than 1. So this one is going to be m squared e to the power mx. So for complementary solution, y prime prime minus y should be 0, and then m squared e to the power mx minus this should be 0. So we know how to do it, and then we know how we came about it. So this is minus 1 is equal to 0. This is never 0, right? And then we have m squared minus 1 is equal to 0, and then m squared is equal to 1. Take square root on both sides. Take square root on both sides, and m will be equal to 1. Now m is equal to 1. Here it means that it is a double root. Don't forget, this is a double root, right? Because we are having 1, and this is kind of, oh, this is not double root. This is going to be plus or minus 1. Sorry, this is going to be plus or minus 1. So let's assume that m1 is 1 and m2 is equal to minus 1. So complementary solution, c1 e to the power m1 x, c2 e to the power m2x. Is that right? Good. Then we can have complementary solution c1 mx plus c2 e minus x. And as I said, this one is very simple to write your particular solution, the trial one. So u1 e to the power x plus u2 e to the power minus x. And u1 and u2 are the functions that we need to find. And this one will help us to write y1, which is e to the power x, and then y2, which is e to the power minus x, from this and that. Then we ask ourselves, what is Jn of x? Jn of x is the natural log of x. So we are going to have the natural log of x. Then the last thing that we need to start looking for u1 and u2 is the Wronskian. So ex, e minus x. When I differentiate this, I get the same thing. And when I differentiate this, I get minus that. Good. Let's do the Wronskian. Multiply this by this, and we are going to have e to the power minus e to the power 0. Do you agree that this is e to the power 0? Because when I multiply this one by this, the base are the same, so I add the exponent. So this is what I'm going to get. Minus, then multiply this one by this to the same thing, e to the power 0. So this is minus 1, which is equal to minus 2. And this is not 0. So now that we know the Wronskian, we know everything. We write u1 minus y2 Jn of x, the Wronskian, dx, and u2 y1 Jn of x. So you see that this is very simple, more than the undetermined coefficient. I love this ones because as soon as the question, unless the question is saying that use undetermined coefficient, that's when I use it. But if the question is open, I love using this because I know how to do the integration and doing the differentiation. So choose the one that you think you can do the best. And you can do this one when you practice too as well. So now let's find u1. u1 is minus, what is y2? y2 is this times this. Wronskian is that. So this is e to the power minus x, natural log of x. Wronskian is minus 2 dx. So this is going to give us 1 over 2 e to the power minus x. Wow. This is like crazy. So I have an exponential function, and then I have a length function. So it means that basically this one is going to be very difficult for us to do the integration. But let's try and see. So this one, I'm going to use integration by part, yes. But what should be my u? My u should be a length. So anytime you are doing integration by part and you see a length function, your u should be a length function. So I'll let u to be equal to the length function, and then it means that the vin will be equal to e to the power minus x dx. So if this one is equal to u, then everything left is going to be the vin. So let's find the u over dx. When I differentiate a length function, it is 1 over what is inside the parentheses, all times when I differentiate what is inside the parentheses, which is going to be 1. So it means that the u will be equal to 1 over x dx. Now let's integrate this guy to here and see what we get from this. So vin will be maintain the function and divided by the derivative of the top, which is minus 1. So this is minus this. So we are using integration by part, which says as u the vin is equal to u vin minus vin du. So now let's do the substitution. So now our u1 will be equal to 1 over 2 in bracket. So we want to follow suit from here. So u times vin is going to give us minus ln of x and then let me say plus um oh no, times e to the power minus 2x, then minus then is minus e to the power minus x times du is 1 over x dx. So this is a lot of work here. So this is minus no 1 over 2. Then this is going to give us minus ln of x e to the power this, then plus integration e to the power x divided by x dx. Now when we integrate this one again, we are going to go back to where we started, right? So it's kind of like we can use reduction function to do this, right? Integration by reduction. So let me just do that for you and we'll see how we can do it again. So I'm going to do the integration again, but I want to do it in a such a way that I come back to the question again, this one, the one that's in terms of E and this one, so that I can use a reduction form to solve this. So let's go again. So because I want to use the reduction, I'll let u to be equal to the e to the power minus x, and then the vein will be equal to 1 over x. Good, dx. So when I differentiate this with respect to x, I'm going to have minus e minus x, and then this is going to give us du is equal to minus x dx. Integrate this, integrate this. Now, when I integrate 1 over x, I get the natural log of x. So basically, I want to go back again. So what I'm doing here is basically for this guy here. So let's see what happens. Good. So I'm just doing what is inside the bracket here. So this is going to be e to the power minus x divided by x dx, which is equal to, so we need to do u times this, which is going to give us the ln of e minus x ln x e minus x, and then minus then this. So this is going to be then times minus e minus x dx. So what are we going to get from this? This is going to give us something like this: ln of x e minus x minus, so this one will be plus. Now I'm going to have let me see how the function is. Good. So I'm going to have e minus x. Good. So I'm going to use reduction method to do this. Now I'm going to plug in, since this is now equal to this, I'm going to plug in this inside that. So let's see what we get. Now u1 is going to give us 1 over 2 in bracket minus ln of x e to the power minus s, then plus. So now this guy here is basically equal to what is here, right? So let's see what happened. This is going to give us this. This integration is crazy. So if I do this, it means that I'm even going back to 0 again. So minus x plus e to the power minus x ln of x dx. And this will cancel this. And this is going to be crazy because it's not going to work. Is it going to work? No. No. So it means that when you use the reduction tool, it's not going to work. So what we can do is we can leave our integration in this form. So we can write this one as ln x e to the power minus x divided by 2 plus 1 over 2 e to the power minus x divided by x dx. So we just leave it like this, right? Just leave it like this and go for u2. So u2 is going to be integration of y1. What is y1? y1 is e to the power x times ln x. So e to the power x times ln x, and then the Wronskian was -2. So -2 dx. So this one too is going to be the same thing like the one we did. We cannot integrate everything. So we integrate and we leave it somewhere, and then we are done. So the same thing, let u to be equal to ln of x, differentiate u and get 1 over x dx, and let divin to be equal to e to the power x dx, and vin will be equal to e to the power x. So it means that our u2 will be equal to -1, open bracket, integration by part u times vin. So we are going to have ln of x e to the power x minus integration of x times 1 over x dx. So when I simplify this, and I'm going to have something like this, I'm going to have something like this. So I'm going to have something like this. Ln of x e to the power x divided by 2 minus, and then this one will be plus 1 over 2 integration e to the power x divided by x dx. So this one too will be my u2. So what I'm going to do now is just plug them inside the particular solution and then done. So we just need to leave it that way, and then we are done. So let me just move the complementary solution and particular solution to the next page, and then we are done. So with this, after this, I just give you the trial question and then you are done. So yp now is equal to, we saw that y1 was equal to this. So let me just do copy and paste. This is equal to this here. So we have this one all times ex, then plus y2, we had this. So I copy this and then paste it again. So plus this one was u2. So u2 all times e to the power minus x. So that's what we are going to get for yp. So our general solution is basically going to be, so general solution, our general solution is going to be basically y is equal to c1 e to the power x plus c2 e to the power minus x plus the particular solution here, which is ln of x e to the power minus x divided by 2 plus 1 over 2 times, plus 1 over 2 integration of e minus x over x dx times ex plus minus ln of x ex divided by 2 plus 1 over 2 ex divided by x dx times e to the power minus x. So this is our general solution at the end of this video. So this is the general solution here. Now, I'll give you this trial question, and this is very interesting. So the integration is kind of very tough. So please, I'll see who gets it right first. So please solve it and leave your final answer in the comment section. So for Math 202, I'm sure I'm ending the video here, and then the rest of the thing that we are going to learn, we can take it to ordinary differential equation when we get to level 400. So I'll just end the video here, and the next video that's going to come up is advanced calculus 1. So as you are going, we can just also learn advanced calculus. So we are going to learn advanced calculus 1 in the next videos that I'm going to schedule. All right, so I wish you all the best in your exams, and I think, yes, I'll do videos on exam question, for us to combine everything together to prepare ourselves for the exams. So see you in the next video.